In this video, we're going to solve Charles law problems. So this is a formula: B1 over T1 equals B2 over T2 at a constant pressure. So let's solve number 1. So problem number 1, what volume will a sample of nitrogen occupy at 27 degrees Celsius if the gas occupies a volume of 400 cubic centimeter at a temperature of 0 degrees Celsius? Assume the pressure remains constant. So let's begin. Here, let's solve the number 1. Right, number 1, we have at 27 degrees Celsius. So this is a temperature 2. Okay, temperature 2 equals 27 degrees Celsius. Convert it to Kelvin plus 273.15 Kelvin equals to 27 plus 273.15, which is 300.15 Kelvin. Okay, and how about their volume? Volume as there's a volume 1. Okay, volume 1 has a 400 cubic centimeter, and temperature 1 equals 0 degrees Celsius. So 0 degrees Celsius. 0 degrees Celsius plus 273.15 Kelvin equals to 273.15 Kelvin. Okay? And how about the volume 2? Volume 2 is a known, so we need to solve it. So this is a solution. So we need to use the formula, which is B1 over T1 equals B2 over T2. So B1 over T1 equals B2 over T2. So we need to find the volume 2. So in here, multiply temperature 2 here. Multiply. Let's derive. So B1 over T1 times T2, multiply by its both sides, equals to volume 2. So volume 2 equals T2 times B1 divided by T1. So B1 T2 over T1 is equals to volume 2. Okay? Did you understand it? And in volume 1, we need to plug in now the values. The volume 1 is given here, which is 400 cubic centimeter. So 400 cubic centimeter. And how about in temperature 2? Temperature 2 has 300.15 Kelvin. So it's 300.15 Kelvin. And the temperature 1, which is 273.15 Kelvin. So 273.15 Kelvin is equals to volume 2. So cancel out by Kelvin. So the left is cubic centimeter. So equals to volume 400 times 300.15 divided by 273.15 is equals to 439.53 cubic centimeter. So that's your final answer. Okay. How about in problem number 2? So in problem number 2, if the gas occupies the volume of 700 cubic centimeter at 10 degrees Celsius, at what temperature will it occupy a volume of 1000 cubic centimeter if the pressure remains constant? So we need to find the temperature 2, the final temperature. So let's begin number 2. So in number 2, we have a volume 1 of 700 cubic centimeter. So volume 1 equals to 700 cubic centimeter. Then it has a temperature 1. Temperature 1 is as 10 degrees Celsius. So temperature 1 equals 10 degrees Celsius plus 273.15 Kelvin is equals to 283.15 Kelvin. And how about in volume 2? So the volume 2 equals 1000 cubic centimeter. So we write volume 2 equals 1000 cubic centimeter, and the temperature 2, or the final temperature, is unknown, so we need to solve that. So let's begin. Solution. So B1 over T1 equals to B2 over T2. So we need to cross multiply each. Cross multiply. Okay. So B1 times T2. So B1 times T2 is equals to T1 times B2. So B2 times T1. Okay. We need to find the temperature 2 again. So divide both sides by volume 1. Then cancel out. So your temperature 2 is equals to volume 2 times T1 over volume 1. So temperature 2, you need to plug in those values. So in volume 2, what is the value? 1000 cubic centimeter. So 1000 cubic centimeter times temperature 1 equals 283.15 Kelvin. 283.15 Kelvin. And divided by, what is the volume 1 again? Volume 1 equals 700 cubic centimeter. So volume 1 equals 700 cubic centimeter. So cancel out cubic centimeter, and the left is Kelvin. So temperature 2 is equals to 1000 times 283.15 divided by 700 cubic centimeter equals to 404.5 Kelvin. And you need to convert Kelvin to Celsius. So 404.5 Kelvin minus 273.15 Kelvin. So equals temperature 2 is equals to 404.5 minus 273.15 is equals to 131.35 degrees Celsius. So that is your final answer. But it's okay if you want this to final answer. It is the same, right? But it is the final answer. Okay. So we continue in Gay Low Sucks Low. So please like and subscribe.